Like we did yesterday, guys, we came up with this statement yesterday. We called this a conditional statement. We turned, still 2-2, yes. We turned this, remember we said perpendicular lines intersect. That was a generic observation, what do we call that? It was called, conjecture, thank you, I forgot what it was called. We had the generic conjecture of perpendicular lines intersect. We turned that conjecture into an if-then statement. And what we came up with was, if lines are perpendicular, then they intersect. Makes sense, because if they weren't perpendicular, they weren't going to be intersecting. So what we did then is that we had this as a, our if and then, our original and the conclusion, okay? So not the science homework, the math notes, paper.
But isn't this kind of science?
What's that?
Isn't this kind of like science?
It is a little bit here. What we're doing, what we are doing is a little bit of that. It's more of a logic than it is anything. This brought up in first hour as well. Over the past couple of years, we haven't spent as much time on this logic portion because we had other materials and things that we were, our curriculum was geared towards. And when we started to look back at how things have worked out with how students do on proofs and how their reasoning skills work out later on, we've come to a rationalization that we kind of need to spend a little bit of time on things like this. And granted, we don't spend a ton of time, maybe 2-3 days total on logic, but we're hoping that this year will be a little bit different than the past couple as far as when you start to work on proofs, which we will in a couple of weeks, you won't be so, crap, I'm scared. But yet you'll have an idea of, okay, logically, what should I do first? And this is the idea that we're coming up with, to give you guys a little bit of a background for how to think. And that's all logic is, it's just a way of thinking. So if I start with this one, we called this, remember the nomenclature we had yesterday? P implies Q?
Yep.
And that's what we used. This is called our conditional statement. Our conditional statement, our P implies Q. Hypothesis, conclusion, cause and effect, something like that. Now, there are other ways to rewrite these conditional statements. What we do is we go through a battery of rewrites and negations. Do you guys know what it means to negate something? No. I like you. Negate that.
You just made.
I don't like you.
You just made a judgment about me. So
No, I was just asking you a question to negate the statement. Negate. I don't like you.
Wait, no, you don't like me.
I like you.
You like me.
I don't like you.
You're saying the opposite.
What we're doing is we're negating each other. We're saying the opposite of it. That's all it is. We can flip-flop things and negate things, and we can still come up with statements that are true and false. Now, bear with me. This is weird, but it's not that bad. What we do next is we use what's called a converse. The converse of this statement is to say it backwards. Q implies P. So we're going to have 4 different ways to write this out. We have our conditional. Conditional is your original if-then statement. If it is sunny, then I will wear sunglasses. There you go. P implies Q. Converse is to work it backwards. Exactly. Q implies P. So let's look at this one for this example. If my conditional is if 2 lines are perpendicular, then they intersect. Well, to say that backwards would be if 2 lines intersect, then they are
Perpendicular.
correct. If 2 lines intersect, then they are perpendicular. Now, You just said that was a false statement. Why is that false?
Because two lines that intersect don't have any weight.
Show me a picture.
Would it be like the picture that we was just looking at for problem 17?
Yes, that would work because it's in their perpendicular. Now, here's what we're doing. We're doing true-false statements here. This first statement, if lines are perpendicular, they intersect. Is that true or false?
True.
They would, yeah. Now, if two lines intersect, now if I say it backwards, if two lines intersect, then they are perpendicular. Is that true or false? And what would be an example of that? Give me a counter example. Use your arms. All right? Those aren't perpendicular, correct? They're perpendicular here if I throw the box in it. If I do this, they're not perpendicular, are they? Here's my counter example. Oh, got my little arrows. That's it. I counter example it. Anytime I come up with a false statement, I'm going to throw a counter example in there. Okay? So that's the first means of rewriting these conditionals. The next one is called the inverse. The inverse of the statement is when you take, this is going to be a new symbol for you, not P implies not Q. This symbol here, that means not. Sometimes you'll see it written as a single squiggly, otherwise known as tilde. It also means not. Toss me the eraser over there. Yes, sir.
Oh, so when it's on the top of the equal sign, I mean it's not equal.
What's that?
Because I'm like, I've already seen it on top of the equal sign, I mean it's not equal.
That means something different. That means converts. That's something totally different. If it's just that's why what happens with the single squiggly, it has a couple of different meanings. It means not, and it also means about-ish. Okay? That's why I don't normally use that symbol. I'm going to use this as not a lot more than anything else. I do know that I know that in the page in the book that talks about logic tables, they use this tilde symbol. So if you see it, I just wanted to show you that's what it means, okay? That's all. All right, that's it.
I'm sorry, can I go
Yeah. Yes, sir.
Is it on purpose that P and Q are like mirror images?
I don't believe so. I never even thought of that, to be honest with you. I don't know. But like we talked about yesterday, the whole idea of mind your P's and Q's, this is kind of like where it came from back in the old days. It's the just the idea
You
of
don't have to talk like that.
why not?
Because you talk. Is that mean? I mean,
La puerta está allí.
That
Adios.
was so scary.
So I never thought of that, Luke. I really haven't. It's a great question. I'll see if I can find an answer for it. So inverse, we go back to the conditional statement, the original statement, and we put the word not in there twice. If two lines are not perpendicular, then they do not intersect. So, inverse. Not P implies not Q. If two lines are not perpendicular, then they do not intersect. Is that true or false? Right. Which is it?
True.
Who says true? Who says false?
That's some hype beats.
Who's not trying?
Yeah.
at least you're being honest.
I need.
Look, it looks like our parade is going to get pretty soon.
Everybody here.
Way
Way to go, Riley.
No, I tried.
Way to go.
Oh, that's
Way to go.
That's true.
Yes, it's true. I have to.
I love it, turn around.
Hey, can you do this?
Thank you. So, here's a line. Put your line so it's not perpendicular to it. Oh, wait. Did they still, are they not intersecting or are they intersecting?
There are intersections.
They're not perpendicular, they still can intersect. Or could they not if they're not perpendicular, they could also be parallel, couldn't they? So parallel. They're not intersecting, are they?
No.
They're not perpendicular, are they? Are you just carving examples? So is that a true or false statement? Guys, I'm really thinking I have to move all four of you, and I haven't had to move anybody yet this year. Okay? Go parallel again. They're not perpendicular, are they? They're not intersecting, are they? Is it true or false? Don't make no sense means it makes sense because it's double negative.
It still doesn't make any sense.
This is also false because we could be parallel. They could be parallel. Or you can throw the slash. Remember how we showed slash before for parallel? They don't intersect and they're not perpendicular. They're parallel. That happens. It's a false statement. And then the very last one, excuse me, the very last one is the weirdly named one. And I don't really like to go by all the names all the time. I like to just kind of show you guys the pattern in the lettering of the nomenclature. It's called the contrapositive. Now, if you look at where we started from, P implies Q, Q implies P, not P implies not Q. What do you think the next one's going to be?
Not
P implies
and not
Q.
Q.
We already have that one.
Not Q implies
No,
P.
like
Not Q implies
P.
that's
not P.
Also.
That's what I meant.
So not Q is not P. So what I want you guys to get in the habit of is understand conditional P to Q, converse Q to P, inverse. Since there's an that doesn't work for that one. Not then you restart it. Not P, not Q. Contrapositive. Then you flip it again. So original, flipped, original no, flipped no.
Is there? I feel like is there like two? Is there more?
No, that's all there is.
Oh really?
Yeah, that's all there
Did you
is.
say that again? Original flip.
That again, original flip.
No, could you say
Original, PQ. Converse, flip, QP. Inverse, original knots. Contrapositive, original flip knots. If I could do a flip, that's not going to happen.
You should try.
No,
do a backflip?
no.
No.
I did.
He doesn't have his
No.
knees wrapped.
We were camping this summer, and one of our friends were with us, and their son, I want to say, maybe 10, and we were in a pot, they had like a swimming pond in one of this places we had camped out, and they had giant inflatable rafts. So kids were jumping off the rafts and stuff like that, having fun. Some kids were trying to do flips. So he was 10-year-old, he's trying to do a flip, and he's up at the very top, and he keeps falling over, and he's not making it. So I'm like a giant child when it comes to like messing around and having fun, and that's just how I am. So my son, Daddy, you do a flip. I'm like, this isn't gonna end well. Because I'm old, exactly. So here I am, you know, I'm old. Ace straps, got my ace strap bandages ready to go. I'm, you know, 8 feet off the water, and on something that doesn't bounce because it's an inflatable. It's like a giant one of those towers that you climb up. So I just kind of did a quick little tuck roll. I landed it, and I didn't die. I'm so proud of myself.
15% or 85%?
What campground were you at?
What's the name of it? It's out in Watertown, River's Edge. We've been going there like once a year. It's a lot of fun. It's just they got water. It's not like a regular.
I was thinking of like high tide.
Yeah, high tide's like that too.
Yeah.
This place up there, it's just outside of Janesville. They have a couple water slides and really, it's not like your fancy regular, you know, go out in the woods campground. But we found it, and it's great for groups. So that's why we go there.
They have a lot less rules than high tide.
So we negate if two lines are not. Oop. Did I flip flop it here? Oh, there we go. If two lines do not intersect, then they are not perpendicular. Is that true or false?
Wait.
If two lines do not intersect, then they are not perpendicular. That's false.
Bless you.
Wait, that's true.
Yeah, that's true.
That's true.
Yeah, if two lines do not intersect, then they're not going to be perpendicular. That's true.
Yeah.
Now, what happens a lot of times with these truth tables, what happens a lot of times is that your first and last ones are usually true, and your middle ones are usually false. Don't automatically think that's always going to happen, but it's kind of a pattern that does occur with pretty regular. Yes, sir?
You say you're like really confused with some kind of
Yeah.
you just assume it's
It's not the worst plan to start with, but at least that'll help you come up with your conditional statement. Let's see if I can come up with a. I think I have one to work off with here. Where was it? Here is your generic statement, if you will. Okay. What I want to do is come up with the conditional statement. Notice this is not written in terms of if-then. You have just the statement of vertical angles are congruent. We agree that that's a true statement, correct? Okay, and we agree that's a true statement. How do I rewrite that, so that it says it in if-then? Sir? You're making it more difficult than you need to. Think about your original, what are they saying first?
If the angles are vertical, then they are congruent.
Perfect. See how it's starting with what they're coming up with as your generic statement. Vertical angles are congruent. Well, so your if part is the vertical angle. Your then part is congruent. So if angles are vertical,
They are congruent. Well, then they are congruent.
so are conditional. If angles are vertical angles, then they are and Jerron, there's that symbol you were talking about earlier with the squiggly with the equal. That's what congruent stands for. All right. Now, what would I do for the converse?
Flip it. So you would say, if the If they are congruent, then the angles are vertical.
Okay, perfect. So the conditional statement is your P to Q. Your converse is going backwards, Q to P. Now, I really, really hope you guys are writing down what each one of these statements stand for as you're going through that. Believe me, it's going to help you as we go through this. So I say it backwards. If angles are congruent, then they are vertical. Yes, sir. Oh, but we forgot to say from the first part. Was our first conditional statement, if angles are vertical angles, then they are congruent. Is that true or false? True. That's a true statement. That's a true statement. If angles are congruent, then they are vertical angles. Is that true or false?
False.
What's your counterexample? What's your counterexample if that's false? Anytime you say false, you got to give me a counterexample. Why are they false? Why is that statement false? Why is that false? Can you have parallel lines?
Oh,
What would I do to show that two angles are congruent but they're not vertical? No, we don't. What do you mean by horizontal? That's what you were saying there.
but it's an angle.
Can't I just do this? Doesn't that just mean that in that triangle, those two angles are congruent?
Yeah.
Does it mean that they are vertical? No. That's it.
What is that little thing with the two underlined twice?
It's a congruent symbol. This is that tilde. Sorry. Sometimes, you should know by now, my handwriting is somewhat suspect. I just was writing it off the set. That's all it was.
I thought that was a 2-2.
Not a 4-4?
I thought that was a 2 also.
I want you to write this sentence for me. I want you to figure this out. You cannot embellish the words, you can't change the order, you cannot do anything else, but you need to write this down. There are 3 2s in the English language. How do you write that?
Oh.
Oh.
How do you write that?
Wait.
That.
There are 3 2s.
Oh, no, what? You can't do that. You know, it's like T-O-O-T-O-T, like the actual.
You just got it, didn't you?
I got it.
How do you, I mean, seriously, think about it. How do you write that?
There are 3.
That's it?
It.
No, I was saying.
What? You can't get that right.
You can't. How'd you write it? You're adding too many words. You have to say it exactly the way, you have to write it exactly the way I wrote it, or the way I said it. There are 3 2s in the English language. How do you write that?
Can I write it?
I just wrote the number two.
Isn't it?
Like there are 3.
But how do you know which one you're supposed to write?
You just know.
How?
You just know. I feel like just T-O, but
Oh, there, you got me.
I don't know. Here.
No, I thought it was 3, like the number. Or, I don't know. There are 3.
it has to be T-O.
Does it?
You know you do.
Maybe not.
All right. Anyway, so back to this. I love that question. It's a great question.
Wait,
What do you got? I don't know.
Let me see.
I don't know. I have a degree in math. I have no idea. Inverse.
But 2s isn't a word.
That's it.
No, it's
That's
not.
No, because then the 2 is.
a great way to
There
think
are
about it.
3 2 is and
No.
no.
No. It was like,
Yes.
yes.
It's still not a word, I'm sorry.
All right. I think we finally found our answer. I think that's right. All right, let's finish this real quick before we run out of time. Let's finish this real quick, and then we'll go back over our twos question. The inverse. What do you negate on the inverse? Yes.
If the angles are not vertical, then they are not congruent.
Okay. The angles are not vertical, then they are not congruent. So remember, it's not P implies not Q. If the angles are not vertical, then they are not congruent. True or false?
False,
Why?
because
Because there can be congruent angles that are not vertical.
Okay. Do I already have an example of that on the board
Yes.
somewhere? And that's the thing. A lot of times you might get away with being able to reuse your exact same counterexample. Because inside of a triangle, those two angles are congruent. They're not vertical, but they're still congruent. Okay. And then last but not least, the contrapositive. If they are not congruent, then they are not vertical. True or false?
True.
True. Bless you. Not Q. If the angles are not congruent, then they are not vertical. And that's true. Okay. Really what I want you guys to get at here is, can we rewrite statements in terms of logic? So that was what we got.
This isn't related, but I was just curious.
We never go off topic in this class.
Well,
We just did.
It's a joke.
Kiki.
Hold on, guys. Hold on.
if I did something like that,
Yeah.
and then that,
Yeah.
would that make it a
No, it doesn't necessarily make it a 90-degree angle. Oh, I'm sorry. You did put the angle in there? Okay. Now, that could be a 90-degree angle if you're on a sphere. But when we're talking linear, normally, even though you say it's a 90-degree angle, what they will do is they will make sure it looks like it's going to be a 90-degree angle.
But can still
Nice. What's that?
still be
Implied that it is?
yeah.
Yeah, it can, because that's what the diagram says. But you're not going to see it that skewed off, if that makes any sense. You're going to see it more as, yeah, it's going to be straight up. Yeah. That's a good question. So, like I'm saying here, guys, what we're working on today really is going to be these kind of statements. Can we rewrite things that they can show this this almost uniformity of as far as how the statements interact with one another? There's no real. There are ways of doing this completely wrong. Hopefully, we don't do that. But there are a few reasons that we go through these, because one of the things that we're going to talk about tomorrow is going to be what's called a biconditional statement. A biconditional statement is like most definitions in geometry or in math. They work the same going forward and backwards. As much as I'd like to, get ahead of the other classes, I'm going to call it quits here, because first hour is kind of where we stopped at, and I want to give you guys afford you guys the same amount of time to get some work done. The problems that I had for you guys to do was, again, in section 2.2. I think it flips over to the next page of 83, if I'm not mistaken. Yeah. We go over to the next page on, excuse me, so it's page 83. I'll put it on the smartboard here also. It was 7 through 10 and then 22 through 25. Now, you're going to be very happy to know that there is really no math. You don't have to solve for X or anything like that. It's these statements. You're writing these out. So it's the next section, or same section, excuse me. Now, the first 4 questions they're giving you the statement. You have to come up with the conditional, converse, inverse, contrapositive. For example, the very first one states, complementary angles add to 90 degrees, which means you got to turn that into the conditional statement. You got to turn it into an if-then. Complementary angles add to 90. So if-then would be, if angles are complementary, then they add to 90. That's how that works. So you've got 4 of those to work through. Please, as you're writing those out, like I did on the notes here, notice how I wrote conditional, converse, inverse, contrapositive. Underneath each one of them, I wrote down the relationship of P's and Q's. Write that as you're doing it, guys. It will help you. It will. Believe it or not, there is method to my madness. It's weird, but I do really mean well. Hard to believe. Okay? We'll get started. I'll give you guys a couple extra minutes today. Tomorrow, the biconditional statement will take all of 5 minutes, and then we have the rest of the period to work on these logic puzzle competitions that I have.
Mr. Murphy,
Yes, sir.
have you noticed that any pencil that's not a Ticonderoga is trash?